All right, here in Unit 2, we are going to start talking about the different tools that we use in science. And some of the most important tools that we use in science have to do with measuring. So learning how to measure in science is actually a very important skill that will not only be used right now, but also throughout the rest of the semester. So let's get started going through some of the different things that we can measure, talk about how we measure them, and what we can actually do to, and how we need to make sure that we're recording our measurements correctly. The first measurement we're going to talk about is length, and length is defined as the straight line distance between 2 points. And the measuring tool that we use for this is the ruler. Now, if you look at the scale on a ruler, most rulers have 2 sides. Our meter sticks have 2 sides, and the regular rulers that we use in class, for instance, also have 2 sides. One side has metric markings, and the other side has standard markings. We always will use the metric side of the ruler. And if you look at the metric side of the ruler, the numbers on there represent the centimeters, and the little divisions in there represent the millimeters. There are 10 millimeters for every centimeter, and for instance on a meter stick, then we also have 100 centimeters for every meter. You need to make sure that you are using the appropriate unit, whether that's a meter, a centimeter, or millimeter, to record your measurements. And that's just going to depend a little bit on what you're actually measuring. When you measure, you always add one value, a guess, that goes beyond the smallest division. So what you're trying to do is actually read in between the lines. So what does that mean? Well, if I look at, for instance, if I'm measuring in meters, okay, and I'm recording my measurement in meters, then any numbers that come before the decimal point are whole meters. Then the next 2 places that come after the decimal point represent the number of centimeters that I have. Then I can take a look at the next one, which would be the millimeters, so the number of full millimeters that I have. Now, if you're using measurements in other disciplines like math or even engineering, this is usually where you stop. But in science, we always include that little bit of uncertainty because we have to show where our measuring instrument kind of makes us guess. So with all of our measuring tools, all of these other measurements we actually have on our measuring device. So to show that we actually have them, we add another place after the decimal point, which is our guess. So for instance, for any measurement that we take in this class that we put in meters, we should have 4 places after the decimal point. If we're measuring something smaller and we're going to use the unit of centimeters, the spots before the decimal point will be our centimeters places. The one after will be millimeters. And then again, we need an additional place for our guess. If we use something even smaller that we measure in millimeters, then before the decimal point, we have our millimeter mark, or millimeter digit, but we still have to have that guess. And you will see that as we go through some of the practices that we do, how this actually works. So, like I said before, on the ruler, the numbered divisions are for centimeters. So the smallest divisions on any of our measuring devices are for the millimeters. So when we make our guess, we are actually guessing and estimating in between the millimeter divisions. So let's show what this actually does. Let's flip over to your measuring packet with the worksheet that looks like this at the top. Now, what we're going to do first is we're only going to do a couple on here, but let's take a look at letter A. And we're going to record that measurement in centimeters. Letter A, if you look at where the arrow is pointing, it has passed beyond 0 centimeters. So before the decimal place, I have to have the number 0. Now, if I I look at the number of millimeters, now this is where a little bit of interpretation comes in. I look at that arrow and I see that I feel like it has completely gone to 5 millimeter markings, so I can put a 5 there. In fact, I think it's pointing directly at the line, so it's not above or it's not below, so my guess will show it that. So this tells me that I have gone past 5 millimeter markings and that it's right on the line with that 0. Okay. If we look at letter B, it's slightly different. If I look at letter B, it's gone past 3 of the centimeter markings, and then beyond 3, I think it is just short of 3 millimeters past the number 3. So to show that, I'm going to put a 2 here, but it's very close to the 3. So my estimate here would be a 9. Now, for both of these measurements, you could have had some different interpretations. Let's say for letter A, you thought that it was actually short of that 5 millimeter line. Well, that's fine if you had a reading of something like this, or even let's say you interpreted it as being slightly above. All of those are acceptable. What would not be acceptable would be a measurement something like this. Okay, that's too far away, it's too close to the line. Or even something like this. Again, that's too far away or too close to the line. Okay, other acceptable answers for B would be 3.30. Okay, or even 3.28. What matters is less, when I look at these, I look more at, did you record the measurement correctly? In other words, did you include that guess? Okay. If I don't include that guess, that means I'm guessing here. But using my measuring tool, you can see I am not guessing about that number. What I am guessing about is that last digit, and that's what's important in science. All right, so I'm looking, first of all, did you make the right guess? Did you record it correctly? And second of all, is that guess reasonable? All of these that I've listed are reasonable for those measurements. Now, that's if I'm recording in centimeters. The nice thing about changing to millimeters is all I have to do, if I know what I'm doing, is jump the decimal. So for instance, with letter A, I could just take that decimal and jump it one spot and have 5.0 millimeters. And I could do the same thing with letter B at 32.9 millimeters. I leave the rest of those there for you to work through, and if you have questions, please come see me. Now, let's jump down to the bottom of this page with the lines. Now, this is actually probably more along the lines of what we will be doing in this class. So what you want to do is you want to take your ruler and go ahead and measure letter F. When you record your measurement for letter F, you want to record it in centimeters. Okay? So for letter F, I said it went past 3 centimeters, okay, and then I said it went almost to 4, so I made it as 3.39 centimeters. Now you could have it as 3.40 if you wish, but it needs to be reasonable, close to that number. Let's do the same thing for letter G. When I measure letter G, I get a value of 5 centimeters, and it actually ends up kind of halfway in between the 3 and 4 millimeter marks, in between or after 5. So I make it as 5.35 centimeters. Again, you need to have this guess. Now, my one caution to you is oftentimes when I am coming around and helping people with labs, and I mention that they have not recorded their measurements correctly, their first reaction is to put zeros for these guesses on all of their answers. Unfortunately, that is a good way to actually get things marked incorrect, because it's not very likely that all of the measurements are going to be exactly on the line. It is also possible that when working with your lab partner, you could actually find that your measurement is slightly different from your lab partner's. And that's fine, as long as it's reasonable. If you get two numbers that are way different from each other, you may want to have it measured a third time just to double check. All right, so let's look at letter H, and you guys go ahead and measure. When I measure, I came up with 11.49 centimeters. So again, your answer may not be exactly the same as mine, but it needs to be close, and that's the idea here. Okay, the second measurement that we're going to learn about is mass. And mass is defined as the quantity of matter in an object. The measuring tool that we use for this is the balance. Now, we actually have two different types of balances in our lab, okay? The electronic balance is one that we will use from time to time. Simply what you do is you turn on the balance, you wait for it to zero, in other words, all the numbers that first come up need to be zero, and then you read and record all of the given balance or values after you place the object on the tray. Now, the more common one is the triple beam balance. And this is the one we'll use a lot, especially at first. The triple beam balance has 3 bars that represent 3 different values of mass. You're going to add together the value of all of the bars, and then you're going to estimate one value beyond the smallest division, and in this case it's going to be to the 2nd decimal place. So again, if you flip in your packet to the worksheet that looks like this, we're going to go through a couple. All right. Now you can see the 3 beams here, and these are set up just like our balances are. The largest one is in the center, and that's what we start with. And if you think about the way we write a number, okay, this one's got the hundreds, the tens, and then the singles. So that's how we write it. We fill in the number for the hundreds, and then for the tens, and then for the singles. We also have the tenths marking place, and then this place is going to be our guess. Our unit here is grams. So if we look here, each of the top 2 triple beam or beams on the triple beam balance have these little notches. And so this little notch here is actually pointing at 700. So the first number we fill in is a 7. In other words, we are taking 700 plus, then we go up to the top bar, and that one is at 20. So 700 plus 20 gives me 720, and then I go down to the bottom one. Now the slider here is kind of hard to see, but it does have a point down at the bottom that's about right there, if you can see it. Okay, that slider has gone past 2 grams, so 700 plus 20 plus 2 gives me 722. Now I need to count the tenths. If I look at where that arrow is pointing, it's on the 9th one, the one just before the 3. So I would put 0.9, and I'm thinking it's directly on the line, so I'm going to put a 0 there, and my unit is grams. Let's take a look at the second one then. The hundredths place has a 2. The tens place, which is the top row, has 0. And on the bottom slider, it has also not gone past a full gram, so it is also at 0. Now for the tenths, if I count over, I've got 1, 2, 3, 4, it's past the 5, and as you can see, the arrow is actually kind of close to the 5, but it's definitely not on the line. So I'm going to call this 5.2 and put my unit of grams. Just like with length, as long as it is reasonable, any answer would be quite fine. Now, the third value that we need to learn how to measure is temperature. And temperature we measure and define as how hot an object is, and we measure it using a thermometer. Now, we do the same thing as we've done with the others in terms of reading between the lines and adding one value beyond the smallest division. I can't tell you how many decimal places to go, however, because we do have different different thermometers with different scales on them. On some thermometers, each marking on the temperature scale is worth 1 degree. In others, it is a different amount. So you have to really look at your measuring tool and understand how to use it. In science, we have two different scales of the three that exist in the world. Our thermometers measure the Celsius scale. And if you look at Celsius, okay, water freezes at 0 on the Celsius scale, and it boils at 100. The other scale is the Kelvin scale. This is actually the SI scale, but we actually don't use this on our thermometers. In the Kelvin scale, water freezes at 273 and boils at 373. So if you look at the temperature spread between freezing and boiling, they are the same. Each of them is 100 degrees. Also, if you look at that 0 degrees Celsius mark, you can see Kelvin is just simply 273 more. So Celsius and Kelvin are related this way. Celsius plus 273 gives you Kelvin. So let's take a quick look here at some thermometers on your worksheets and talk about how we measure them, or measure with them, I should say. The first thing I want you to notice is if you look at the actual reading part, I'm kind of enlarging it here, it actually kind of bows up. You want to read at the top of that bow in order to read the temperature. So that's the first thing you need to know. So let's look at letter A. The first thing I need to look at here is, how is my scale measured? Well, if I look here, I am starting at 60 and I'm going up to 70. So the value of each of my divisions is 1 degree Celsius. So this big line here is showing me that that's at 5. And then if I count up, I've got 6, 7, and I'm going to say that that bow is right at the line of 8. So my reading would be 68.0, because that's my guess, degrees Celsius. If you had 67.9 or even 68.1, that would be reasonable for this measurement. Now letter B is a little bit tricky because since this is a Celsius thermometer, we can go into negative temperatures. When you're dealing with negative temperatures, you have to start at 0 and work down. So in this case, I've gone past -1, I've gone past -2, but I haven't quite reached -3 yet. So I know I've reached -2, and since I'm close to -3, I'm going to show that with my guess, 0.8. Okay, and again, that would be degrees Celsius. And this is also one that goes by 1 degree for each marking. The last one on this row also goes by 1 degree for each marking. And I'm just above 10 at the next marking up, so I'm going to say that one is 11.0 degrees Celsius. If you look at, for instance, letter E and letter F, those scales are different. Letter E, each tick mark on that thermometer is 0.2 degrees. And for letter F, each tick mark on the thermometer is 2 degrees. So that will change where I actually put my guess. All right, the last value that we need to learn how to measure is volume. Volume is defined as the amount of space an object occupies. And the trick with volume is that there are several ways to measure volume. In other words, there is no one specific measure of volume that we can use for everything. It really depends on some specific characteristics of the material itself. The first method is the direct method, and we use this with liquids because we are measuring in a graduated cylinder. Again, like the thermometer, you have to look at the scale. For instance, we have 2 different types of graduated cylinders that we use in the lab. Our larger 100 milliliter graduated cylinders that you used for the mystery powder lab, each marking on there is 1 milliliter. So I only have to go to 1 decimal place for my guess. But we also have smaller 10 milliliter graduated cylinders, and the tick marks are actually in between the millimeter markings. So I actually have to go to 2 decimal places on that one. So you do have to be careful. The unit is milliliters, ml, or you can also convert it into liters if you need to. So let's take a look at the Measuring Liquids worksheet and take a look at those top 3 graduated cylinder markings. Now, like with the thermometer, we need to kind of orient ourselves a little bit. You'll see that we have a U, that meniscus there, in the graduated cylinder. You need to remember that we read volume at the bottom of that U. Okay? So anything below that is liquid. So if we take a look at number 1, I see the bottom of my U is right there. It's on that line. The second thing is I need to figure out my scale. And if I take a look, I have 50 here and 60 here. This is just like our 100 milliliter graduated cylinders in the lab, where each of these tick marks is worth 1 milliliter. So that means that I need to record my guess in the first place after the decimal. So if I count up, I go 1, 2, 3, 4, 5, and I'm on the 6th line. So this would be 56.0 milliliters. In letter B, I am using a different scale because as I'm going from 3 to 4, then each one of these is 0.1 milliliter. So as I go from 4, I'm above 4, and I go 1, 2, 3, I'm beyond 3, and my meniscus is pretty much halfway between 3 and 4, maybe a little less, so I can make this 4.33 milliliters, although probably 4.35 would also be acceptable, or 3/4, so anywhere in between. Letter C on here, we're back to one that has 1 milliliter in between each of the markings. So in this case, I'm at 20, and then 1, 2, I'm past 3, but I'm not quite to 4. And to me, it looks like I'm a little bit more than halfway, so I'm going to make that 23.7, and my unit is milliliters. So that is when we are dealing with a liquid. Now, obviously, everything that we work with is not a liquid. In fact, many things that we work with are solids. So how do I handle those? Well, we often deal with an indirect measurement for some of these. And this we can use with a regular geometric shape where I have a mathematical formula that if I do a little bit of measuring, I can actually plug things into, like a cube or a sphere. Basically, you use the object that you are measuring, or that you're trying to find the volume of, and you measure certain dimensions. With a cube, you measure diameter to get, with a cube, you measure length, width, and height. With a sphere, you can measure diameter to get radius. And then you plug it into a mathematical formula. So you're going to follow your rules for length because you're going to be using a ruler at that point. And then, I know it says to use the sig fig rules, you're going to multiply. We'll talk about sig fig rules later, but it's important that you understand that when you're doing that, because you're doing a mathematical calculation involving a measurement, you will need to use sig fig rules. The units, because it is a solid, is slightly different than with a liquid, and that is a cubic centimeter. Now, not everything we have has a regular shape, and so what we can also use is something called displacement. Displacement we use with an irregularly shaped solid object. What we do is we put a volume of liquid, usually water, in a graduated cylinder. You have to put enough liquid in that it would completely cover whatever object you're going to put in there. But before you put it in, when you just have the water in there, you need to read the volume for that water as we just described. Then you're going to lower the object that you're trying to find the volume of into the cylinder, and you're going to read the new volume. So the final volume, subtract the first volume. Okay, so final minus the first gives you the volume of the object, because when you lower the object in, the water level is going to go up, and it's going to go up by the amount of space that that object is occupying, or its volume. Now the unit here, even though we are dealing with a liquid, is going to be cubic centimeters, and that's because the object is a solid. And the reason why we can do that is a cubic centimeter and a milliliter actually are the same size. If I set them next to each other, they would occupy the same amount of space. Now we are going to get practice using all of these measurements and taking all of these measurements and using these techniques in a lab coming up. So it is important that you kind of review these and get comfortable. Probably the biggest mistake I see is that you have an estimation or a guess when you record them. Otherwise, they are not correct. Okay, so that's kind of the first part here of the second unit, and we will move on to some other things in the next video.